Welcome to video lesson number 2. In this lesson, we're again going to be reviewing some concepts from grade 9 and taking a look at our periodic tables and just kind of refreshing where everything is, what all the numbers mean, and that kind of stuff. The periodic table crossword on page 4 of your notes booklet is mainly there to help you get acquainted with your periodic table. So periodic table should look like this. And it's there to sort of help you get faster at finding where stuff is. So this is optional if you choose to do it, great. If you choose not to, that's fine. But being fast at finding elements on your periodic table will take practice, and it will save you a lot of time in the long run. If you can look at it and say, okay, I need oxygen, there it is. I need aluminum, there it is. I need magnesium, it's over there. And the more you look at it and the more you work with it, the faster you'll be. But for this lesson, we're going to quickly review some stuff from grade 9. So first of all, on your periodic table, you'll see that there's a number on the top. That is your atomic number, okay, and it indicates the number of protons in the element. So protons have a positive charge. They are in the nucleus. One proton is one positive charge. Then you'll see the symbol for the element, the name of the element, and the atomic mass. The atomic mass is equal to the number of protons plus the number of neutrons. Neutrons are also in the nucleus and have weight, but they are not charged, they're neutral. So in the chart below, you'll be completing all the empty boxes based on sort of the clue that you've been given for each one. I'm going to go through and do number 1 with you guys, and then you can have a chance to try the rest on your own. So atomic number 8, if I look at my periodic table here, atomic number 8 is right there. So it's oxygen. There's the atomic mass. So I'm going to use that information to fill this out. The element was oxygen. The element symbol is O. The mass number, now you'll see how it says atomic mass here, but here it says mass number. The mass number is the atomic mass rounded to the nearest whole number. So you'll see in the periodic table that your atomic mass is going to be something that's going to have a few decimal places. So anywhere from 1 to 6 or 7 different decimal places. So we're rounded to the nearest whole number. Now in this case with oxygen, we have an atomic mass of 15.9994. So we're going to round that to the nearest whole number to give us the mass number, which is 16. Atomic number was given to us, that was 8. Number of protons, these will always be equal, so also 8. The number of electrons in a neutral atom will also be equal to the number of protons. So we'll add a little note there, equal in a neutral atom, as opposed to a charged ion, which we'll get to in a little bit. So in this case, also 8. Number of neutrons, this will not always be the same as the number of protons. The number of neutrons is equal to the mass number, okay, which is over here, minus the number of protons. So in this case, we would take 16 minus 8 equals 8 neutrons. So in this case, it is equal, but it will not always be this way. It could be 9, it could be 7, it could be different for different elements. So just know that sometimes the neutrons and the protons will be the same number, but not always. That's not a rule. You have to do the math. So looking at the next view, we have phosphorus. Phosphorus on your periodic table is right here, phosphorus. So you'll use the information from your periodic table to fill in the blank. Br, okay, is bromine, Br right there. Again, use the information from the periodic table to fill in the chart. Finally, something with a number of protons, that's 19. Remember that protons and atomic number are always the same. So we're looking for the element with the atomic number 19, which on your periodic table is potassium. So there you go, there's 19. So again, using the information here to fill in the chart. So if you have your periodic table with you and you're ready, pause the video for a few minutes and fill in the chart. I will post the completed chart in the answers document so that you can check your work and make sure that you got it all right if you want to check that afterwards. After you do that, you can restart the video and we'll continue on looking at how the periodic table is organized. So the periodic table is organized into metals and non-metals, really are the two main distinctions. So on your periodic table, the distinction between metals and non-metals occurs over on the right-hand side. So I'm going to do a little mark and it goes down like a staircase. So you'll want to mark this on your periodic table. Hopefully you can see that highlighted line there. But basically this divide is the line between this side is the non-metals and this side are all the metals. So I'll just sort of put that in there to make it easy to see. So these are your non-metals, these are your non-metals. There's one exception, okay, and that's hydrogen. So hydrogen is over here on the periodic table, but it is a non-metal. Now your non-metals are kind of this group, but your metals can be further categorized by a few different types of metals, and that's what this table is about. So here, giving some examples of metals, we could have something like, let's try and make a bit of space here. I'm going to zoom out a little bit just so that we can get the periodic table in the view a little bit better. So some metals, we can kind of pick any of these as examples. We're just going to list a few examples here. So they're on the left side. Oops, spelled left wrong. Left side of the periodic table. Okay, some examples would be, let's say, calcium, copper, rubidium, lead. Really, these are all technically all metals. Your transition metals specifically are the center portion. So if you're looking at a periodic table, it kind of looks like this. And the transition metals are this chunk in the middle. Okay, so some examples in here. So from here over to here, these are your transition metals. Examples could be manganese, cobalt, so manganese, cobalt, zinc, silver, cadmium, etc. Your metalloids, when you're looking at your periodic table, again, if we're kind of drawing out a little sketch here, your metalloids are between the transition metals and the staircase that divide out your non-metals. So it's this area in here, or your metalloids. So kind of in this chunk. So some examples would be aluminum. So So aluminum's right there. Tin, polonium. Oh, I just wrote the word tin instead of giving the symbol, just to keep things the same. Lead, right there, so on and so forth. And then your nonmetals are all the things on the right side of the staircase, plus hydrogen as a special case. So everything over here, plus hydrogen over in the corner. So again, some examples, we've got oxygen is right there. We've got bromine, we've got xenon, and arsenic, and so on. So a few examples in each spot. So now that we know the general areas of the periodic table, okay, we also have more specific groups, or they're also called families, within the periodic table that further break down those groups into some special cases. So I'm gonna bring the periodic table back and we'll label these. So your alkali metals are your group 1 metals, and these are the very first column of the periodic table. So you may wish to label on your periodic table down here, either at the bottom or at the top. It does not include hydrogen. Hydrogen is with the nonmetals, but this first group are called the alkali metals. The alkali metals, or group 1 metals, we can list them here. So lithium, sodium, potassium, rubidium are some examples. It goes on, cesium, francium. That whole first column are your alkali metals. Then your alkaline earth metals is group number 2. So next row or column over are your alkaline earth metals. You want to label that. The first 4 elements in that column are beryllium, magnesium, calcium, and strontium. So beryllium, magnesium, calcium, strontium. The next 2 important families are both nonmetals. So these are both metal groups that are important. These ones are nonmetals. So we're going to look more over onto this side here. This group at the second to last are the halogens. So this group here are the halogens. Label that. Listing the first 4 elements, we've got fluorine, chlorine, bromine, and iodine. Fluorine, chlorine, bromine, iodine. And our final group, special family, are the noble gases, which is the very last column. So noble gases are this last column. So helium, neon, argon, krypton, xenon, and radon. First 4 elements are helium, neon, argon, and krypton. All right, moving on. Another thing that you would have done in grade 9, and so this is again a bit of review, is Bohr-Rutherford diagrams. Bohr-Rutherford diagrams tell us the number of protons, the number of neutrons, the number of electrons, and the dispersion of the electrons around the nucleus. So we'll do an example. Sodium. We're going to draw the nucleus. Within the nucleus, we have the protons and the neutrons. So sodium, looking for sodium on our periodic table, is right here. It has atomic number 11, which means that it has 11 protons. The mass number, 22.989, rounded to 23. So the number of neutrons is going to be 23 minus 11. So that gives us 12 neutrons. And this is just a sodium atom. It's neutral, so it will have equal numbers of protons and electrons. So we need to add in 11 electrons. Now you may remember that there are different shells in an element that can house a certain number of electrons. So the first shell, or energy level, they're also called energy levels, can house 2 electrons. So we draw the electrons on like little dots. So that's 2, but we have 11 total to put on, so we need another shell or energy level. And the next level can house 8 electrons. Now, these electrons are going to be dispersed in a specific way. So the way that you put the electrons around the model is you put 2 at the top, so 1, 2, and then you go around the clock at 3, 6, 9, and then you repeat 3, 6, 9. So 1, 2, 3, 4, 5, then repeat 6, 7, 8. So that brings us to a total of 10 electrons, 8 plus 2. So we have one more electron we need to draw onto our diagram. So we need one more energy level with 1 electron in it. And there's our Bohr-Rutherford diagram for sodium. Let's try a non-metal. This one's nitrogen. Nitrogen on your periodic table is in row number 2 over here. It has atomic number 7. The mass number is 14.006, which means that rounded to the nearest whole number would be 14. So when we draw our nucleus, we're going to have 7 protons. The number of neutrons in this case is 14 minus 7, which is also 7. So 7 neutrons. And we'll have 7 electrons to put around, 2 in the first energy level, and then it's full. Then we can go around again. So that's 1, 2. We have only 7 to put on. So 3, 4, 2 at the top, and then we go around the clock. 4 or 5, that's 6, and that's 7. So now we have 7 protons, 7 neutrons, 7 electrons, and there's our Bohr-Rutherford diagram for nitrogen. If you have any troubles with Bohr-Rutherford diagrams, make sure you come to extra help and I can go through how to do them in a little bit more detail if you don't remember from grade 9. But hopefully this rings a bell and we can keep going. So the number of energy levels or electron shells, that's the rings around the Bohr-Rutherford diagram. Okay, how many energy levels do each of the following elements have? So here, magnesium is here on the periodic table. That's in row number 3. So if you label your rows, 1, 2, 3, 4, 5, 6, and 7, the number for the row is equal to the number of energy levels or orbitals or shells, depending on kind of what you want to call them. So you might want to make a note of that on your periodic table. So numbering them down, the number of the energy level corresponds to the number of the row it is. So if we look at sodium, here's our sodium example. We had 1, 2, 3 rings to fit all of our electrons on, and it's in row number 3. Nitrogen, we had 1, 2 energy levels to fit our electrons on. If you look at nitrogen and follow it over, it is in row number 2. So how many energy levels do each of the following elements have? Magnesium, find it on your periodic table, is in row number 3. So it would have 3. Nitrogen, over here, row number 2. We already did that one. Francium. Francium is here. So that's in row number 7. Selenium is over here. Follow that over. It's in number 4. Iodine is in row number 5. And barium is here in row number 6. So the row is equal to the number of energy levels. All right. The next thing the periodic table can tell us is the number of valence electrons. So depending on where the element is on the periodic table, we can determine how many valence electrons it will have. So the number of valence electrons, what is a valence electron? Okay, they're the electrons in the outermost energy level. So the electrons in the outermost energy level. So going back to our 2 examples here, sodium, the outermost level is this 3rd one. There's 1 electron in that level, so that would be sodium's valence electron. If we look at nitrogen, it has 1, 2, 3, 4, 5 electrons in the outside ring, so it would have 5 valence electrons. How many electrons do each of the following elements have? Hopefully you can maybe see that sodium, for example, is in group number 1, okay, and it has 1 valence electron. So when we count across the columns, that is going to tell us the number of valence electrons. So you can add that to your periodic table. 1, 2, now we skip this middle section all the way over here to 3, 4, 5, 6, 7, and 8. So I'm going to circle those in another color just to make it a little bit easier for my brain. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so the column number is equal to the number of valence electrons. So we can add a little note about that. Sodium here was in group 1. Okay, so it has 1 valence electron. Nitrogen, if we look at nitrogen, it had 1, 2, 3, 4, 5 valence electrons, and it's in column number 5. So let's use that information to figure out what the number of valence electrons is for the other examples. Beryllium here is in column number 2, so it's going to have 2 valence electrons. Sulfur is over here in column number 6, 6 valence electrons. Chlorine here, number 7, so 7 valence electrons. Strontium, oh yes, it is over here. Strontium is in column number 2, so 2. Nitrogen, we already figured that one out, that was 5. And neon is over here in number 8, so it has 8. Awesome. So moving on, this one's a long one, guys, I'm sorry. Got a couple more things left to do. So Lewis dot diagrams are another type of diagram you would have learned in grade 9, similar to Bohr-Rutherford diagrams, but much simpler. So the difference is that a Bohr-Rutherford diagram will give you more information about your elements. It specifically says the number of protons and neutrons, it shows the energy levels, but they are time consuming to create. So a Lewis dot diagram shows only the valence electrons, but they're much faster. So if you understand sort of the mechanics of atoms, you can use them to be much faster at drawing diagrams rather than always doing Bohr-Rutherford diagrams. So Lewis dot diagrams, we'll have a little definition here, show the number and arrangement of an atom's valence electrons So only the valence electrons. Some examples: lithium. When you do a Bohr-Rutherford diagram, you write the symbol for the element, and then you use the same arrangement as we did with the Bohr-Rutherford diagrams, 2 at the top and then around the clock 1 at a time. So when you're thinking about adding them, you want to do the first 2, 1, 2 at the top, and then the third one, the fourth one, and the fifth one are spread out. And then the 6th, 7th, and 8th, you start to pair them up again. So lithium is in group number 1. It has 1 valence electron. So we just put the 1 on. Aluminum is in number 3. So 1, 2, 3. It's over here. This is sort of a shortened cutoff periodic table that only shows the first 20 elements that you'll be filling out for practice. Sulfur is over here. It's in group number 6. So it's going to have 6. So sulfur is 1, 2 at the top, around the clock, 3, 4, 5, and then start to double up 6. So you can pause the video now and work through these practice. So the first 20 elements, you'll draw the symbol and the number of valence electrons, and then answer the question, what trends do the Lewis dot diagrams show in the periodic table? We've already kind of talked about this, but I'll leave it for you to put into a sentence. I will post the answers to this, and then you can check your work after. All right, the last little piece of this note is looking at the difference between an atom and an ion. So an atom is the smallest particle that contains the properties of a specific element. So we can divide atoms into smaller things like protons and electrons and stuff, but an atom is the smallest thing that will have the characteristics of that specific element. So aluminum is shiny and malleable, and copper is sort of a reddish brown color and it's more brittle, things like that. So an atom is neutral. Okay, so it has equal numbers of protons and electrons. When an atom loses or gains electrons, okay, they're left with an overall charge, and that's when they become an ion. An ion is just a charged atom. So it's either going to be positive or negative. So for example, an oxygen atom would just be written as O, versus an oxygen ion would be written as O2 minus. So we would write in the charge depending on how the atom gained or lost electrons. In this specific case, if we look at oxygen, here it is. Okay, it's in group number 8. It has 8 valence electrons, or 8 electrons total, but it would have 6 valence electrons, like you would have seen this in your example on the previous page. But basically, looking at oxygen's Lewis dot diagram, it's going to look like that. So we have 2 sort of open spots here, and for an atom to be really stable and happy, it's going to want to have a full valence shell. So we're going to add in 2 electrons to fill that valence shell. Each electron has a charge of 1 minus. So overall we added 2, so that's where the charge 2 minus comes from. Let's do a couple examples. So magnesium, we'll draw the atom first. So we have 12 protons and 12 neutrons in a magnesium atom. It's in group number 2 on the periodic table, so it's right there if you're looking for it. We're going to draw on 12 electrons. So 2 in the first row, 8 in the second row. Okay, that brings us to 10, but there's a total of 12, so we need a third ring. Magnesium is also in row number 3, so that tells us that it's going to be 3 energy levels. But a magnesium ion has a full valence shell. In this case, it's easier to lose 2 electrons than it is to gain 6 to fill out that shell. So it's going to lose 2. And our new Bohr-Rutherford diagram will look like this. We'll have 12 protons, 12 neutrons, but we'll only have 10 electrons. So 2 in the first shell and 8 in the second shell. And that's going to be our full valence shell on the outside. So now we have 12 protons, but only 10 electrons. So that gives us an overall charge of 2+. To denote the 2+ charge, we put brackets around our diagram and we write 2+ in the top right-hand corner. Okay, and this would be a positive ion, also called a cation. It can go the other way though, like we did with oxygen, where we can gain electrons instead of losing them. So we'll do an example with a fluorine atom. Looking at the periodic table, fluorine is here. It's in group number 7. It's one of the halogens. It has a mass number of 19 and it has an atomic number of 9. So the atomic number 9 tells us that we have 9 protons. 19 minus 9 gives me 10 neutrons. This is a neutral atom, so we're going to have 9 electrons, 2 in the first level. That leaves 7 for the next level. 1, 2 at the top, 3, 4, 5, 6, 7. So that's a total of 9. But we have 1 open spot over here. It's easier to gain 1 than it is to get rid of 7. So fluorine is going to gain 1 electron. Our nucleus will always stay the same, so 9 protons and 10 neutrons. 2 energy levels, 2 electrons in the first one. And now there'll be 8 in the second one, so 6, 7, we gained 1, it goes in there, 8. So now we're looking at 9 positive charges, 10 negative charges, gives us an overall charge of 1 minus, brackets, and a charge. Now when we have the number 1 as the charge, either positive or negative, we don't write the 1 in the corner there, we just put the symbol positive or negative. If it's more than 1, then you have to write the number in. So looking at all the practice questions, okay, you've got a table to fill in looking at the formation of ions and some practice questions looking at Bohr-Rutherford diagrams and charges and electrons and neutrons and protons stuff. So you can complete those for practice, and the completed version will be available in the answers for you to check your work to see if you got it all right. All right.